boys and girls. Today we are going to have another lesson about chemical formulas and equation. Now, you will need to use all the information that you had in the previous classes to better understand this lesson and to easily write the chemical formulas. Now, chemical formula is a combination of chemical symbols and numbers that represent a substance. So basically, chemical formula shows how many atoms of each kind are present in a molecule. For example, we have H2O, which is the chemical formula for water molecule. It tells you that one water molecule made of atoms of hydrogen and oxygen. So the small 2 in a formula is called a subscript. Now, subscript is number written below to the right of a chemical symbol in a formula. It shows how many of that atoms is present in the molecule. So here we have 2 hydrogen, and if there is no subscript, just like here next to the O there is no subscript, that means there is only one atom of that element. Let's have other examples. We have oxygen, O2. Now this means that this molecule contains 2 oxygens. We have glucose, C6H12O6. It means the molecule have 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. And instead of writing all of this, we will just shorten it to C6H12O6. Now, can you tell me what kind of atoms and how many of them are present in the following formula? Now, writing chemical formula kinda differ depending on the bonding, like covalent bond, ionic bond, or whatsoever. Now, the covalent compounds are the one that got the element joined by a covalent bond. The bond is formed between 2 nonmetals, so that's why covalent compounds contain 2 nonmetals. Now, to name the covalent compounds, we use prefixes, just like in this table. This is very important. You need to remember this. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. So, if you saw these prefixes before the name of any atom, it means that the molecule contains that amount of atom. For example, when we say carbon dioxide, it means there is a carbon and 2 oxygen. When you say dinitrogen monoxide, it means there's 2 nitrogen and 1 oxygen. Now for ionic compounds, these compounds are contained of 2 atoms joined together by ionic bond. An ionic bond forms between a metal and nonmetal, so that means we have a metal and nonmetal. And remember, in ionic compound, the atoms are charged. In order to write a formula for an ionic compound, you need to make sure the net charge is 0. Well, I will show you the easiest way to do this. When you're writing chemical formula for an ionic compound, make sure to switch the charges into subscript. But use the subscript right to the other atoms. For example, in this one, we have NaCl. Na ion has a charge of positive 1. Chloride ion has a charge of negative 1. Now switch these 2 charges into subscript and write it next to the other atom. And remember, we don't write the number 1 as a subscript. We can just use the symbol to show that there is only 1 atom of it. Now we have magnesium chloride. Magnesium has a charge of 2 positive. Chloride ion has a charge of 1 negative. Now switch these 2 into subscript and write it down below next to the other atom. We get Mg1Cl2. So the chemical formula for magnesium chloride is MgCl2. In this way, the overall charge of MgCl2 is 0. Now the chemical formulas that we just learned how to use, we can use it in chemical equation to describe a chemical reaction. In a chemical equation, we have reactant and products. The chemical must start from reactants and end up with a product. For example, this one here, we have C plus O2, CO2. Now, to determine which one is reactant and which one is product, you can use the signs. The plus sign separates the formulas of two or more reactant or products from one another. The arrow sign separated the formula of the reactant from the formulas of products. A reactant substance or molecule that participate in a chemical reaction, but product is the substance that forms in a chemical reaction. A chemical equation that has a wrong chemical symbol or formula will not describe the reaction correctly. So you need to make sure you've written the formula and the symbols right. When writing a chemical equation, the total number of atoms of each element in the reactant must equal to the total number of atoms of the element in the products. The process is called balancing equation. For example, C plus O2, CO2. We have one carbon here, there must be one carbon here too. We have two oxygen here, there must be two oxygen here too. See? It's correct, since the equation is balanced. But for example, in this equation, we have Na2O plus H2O. Now, they will form NaOH. We have two Na on this side of the equation, but only one here. So we need to make it 2. How do you do that? You just add number 2 in front of it. That means there is 2 Na, 2O, 2H. Now, let's make sure about the other ones too. We have 2 oxygen and 2 oxygen here. We have 2 hydrogen here and 2 hydrogen here. That means our equation is balanced. The number 2 here is called coefficient. Coefficient is a number that is placed in front of a chemical symbol or a formula. For example, 2CO represent 2 carbon monoxide. The number 2 is the coefficient. For an equation to be balanced, all atoms must be counted. So you must multiply the subscript of each element in a formula by the formula coefficient. For example, 2H2O, we have 2 of 2H. That means 2 multiplied by 2 is 4. We have 4 hydrogen here and only 2 oxygen. And only coefficients are changed, not subscript. Remember that. Changing the subscript is the biggest mistake you would ever make because it changes the formula of the compound. Now look at figure 6 in your book. We have H2 plus O2. The arrow showed that going to form H2O. Now this equation is not balanced. Let's count the atoms. We have 2 hydrogen here and 2 oxygen here. Whereas in the product section, we have 2 hydrogen and only 1 oxygen. How do we do this balance? We need to place coefficient 2 in front of H2O just to make the number of oxygen equal to the number of oxygen in the reactant section. Now we have to count the atoms once again. In the reactant section, we have 2 hydrogen and 2 oxygen. On the other hand, we have 4 hydrogen and 2 oxygen. Now the oxygen number are balanced, but for hydrogen, you see, we have 4 hydrogen and 2. How do we balance this? By placing coefficient 2 in front of H2. Now we have 4 hydrogen here and 2 oxygen. On the other side of the equation, we have the same. So this equation is balanced. Now it's your turn. Try to balance this equation that are not balanced and comment what you got. That's it for today, guys. I hope this lesson was a little bit helpful, even though this would be much more easier if you were in class right now. Anyways, don't forget to answer the self-check question and do the section review as well. And feel free to ask any question regarding the lesson. Good luck. Goodbye.